Problem 7.2.18. Use the step-by-step method to find I sub 0 t. As we discussed in class, we're going to follow these 6 steps. Step number 1, we're going to write the equation I sub L of t equals I sub L infinity plus I sub L 0 plus minus I sub L infinity times e to the negative t over tau, and same thing as I sub 0 of t, I sub 0 of infinity plus I sub 0 0 plus minus I sub 0 infinity, and then e to the negative t over tau. Okay? So we have I sub 0 right here, and then I sub L is gonna go here. So we can just combine these two as a L equivalent, and we'll combine them later when you calculate the tau. Step number 2. For t equals to 0 minus, this is the right before t equals to 0. So the switch is still closed, and then we're going to combine these inductors together as a one line. Then the circuit looks like this. I sub L here, so the current 10 milliamp is going to go here and follow this route because this is the short circuit, and there are blocks in here, so no current will go through that. That means we have I sub L 0 minus, that is 10 milli, and I sub 0 0 minus, we have a 0. Step number 3, for t equals to 0 plus. So 0 plus is right after t equals to 0, so now switch is open. Then circuit looks like this. For t equals to 0 plus, the switch is open right after t equals to 0, and then we have to use 10 milliamp, which is IL 0 minus, and place that into inductor position. The equivalent inductor was there, so we need to replace that inductor with the IL 0 minus value. So this 10 milliamps going into this node, and since this is open, it's gonna go all downward. Therefore, I sub L 0 plus is gonna be 10 milliamp, and I sub 0 0 plus is gonna be 10 milliamp. Step number 4. For t equals more than 5 times of the tau, so I'm gonna call it infinity, long times later, the circuit looks like this. So for this time, we have 10 milliamp going into this node, and it's gonna split into these two way, right? And again, there's an open circuit, so we don't have to worry about this side. The resistance values are 10K, 10K, they're the same one, so the current is going to split it evenly. That means 5 milliamp going down, 5 milliamp going that way. That means we have I sub L infinity is going to be 5 milliamp, and I sub 0 infinity also 5 milliamp. Step number 5, we need to calculate the tau. Tau is L over RTH. So now what is L? L, we have 4 millihenry is parallel to 12 millihenry. Therefore 4 times 12 over 4 plus 12, that is 3 millihenry. For RTH, if you draw the circuit, it looks like this. So now we need to calculate the RTH. So we need to let current source as an open circuit. And if you look at this, we have RTH at the top, okay, and 10K and 10K. Therefore, 10K, 10K, they are series. So the RTH is 20K ohm. Then the tau equals L. We have 3 milli over RTH 20k, and if you take the k denominator to the numerator, it's gonna be micro. Now step number 6. So we are done. I sub L or I sub 0 t equals I sub 0 infinity. So 5 I sub 0 plus, that was a 10 minus infinity e to the negative t over 3 over 20 micro. That is 5 plus 5 e to the negative t over 3 over 20 micro. And it is actually I sub 0 t, and it's the same as I sub L of t because we had the same value for infinity and then plus. So this is the answer.